Hello guys, welcome back. And today's video, let's do some practice problems on past year papers for electrolysis. Question 1. This question is about copper and compounds. Explain why copper is a good conductor of electricity. So copper, it is a metal, right? So if copper is a metal, what will metal have? Metals will have, first of all, delocalized electrons in metallic bonding. So write delocalized electrons and you'll get 1 mark for it. And then you can also say that the movement of electrons, okay? So the movement of electrons will cause electricity to flow very good. So from this you get 2 marks. So the apparatus is used to investigate the electrolysis of copper to sulfate solution with graphite electrodes. Copper is forming at the negative electrode and oxygen forms at positive electrode. State what would be observed at each electrode. So be very careful. We're asking about observations, okay? So it's not asking you to write down equations. So at negative electrode, you would see, since it is copper, you would see pink brown deposit to be formed. If you write down the half equation, you're not going to get any marks, okay? Alright, so at the positive electrode, since oxygen gas is being formed, you would see bubbles of oxygen gas. So you can add here that you can see bubbling occurring. The ionic half equation for the reaction of negative electrode is this. Suggests why this is a reduction reaction. So there's a lot of ways that you can achieve this 1 mark. You can of course say that this is a reduction reaction because Cu2 plus ion gain electrons, or you can say that the Cu2 plus is reduced, okay, from plus 2 on Cu2 plus to 0 on copper. Now explain why the copper 2 sulfate solution becomes paler during electrolysis. So it's giving you 2 marks, so you must mention the blue color first. So in CuSO4, Cu2 plus is responsible for the blue color. And the reason why it becomes paler is because copper 2 ions or Cu2 plus ions are being used up. Okay, so they are running out, so the color is becoming paler. Alright, next question. A student is provided with a bottle containing a colorless solution X, and there goes this question. So why does the student does not use zinc electrodes in her experiment? Reason why she doesn't use zinc electrodes is because we're going to test out dilute sulfuric acid, and if we use zinc electrodes, they are going to react. So that zinc, she does not want, or zinc does not want, okay, let's say. So we can say that she does not want zinc to react with sulfuric acid. Okay, so that should be your answer. Alright, so that is also why we're using carbon and platinum all the time. Now state what is observed at both the anode and the cathode during the electrolysis. So if you know that here, the student knows the products of the electrolysis of dilute sulfuric acid are hydrogen and oxygen. So what you can say, because it's also here oxygen and hydrogen, right? So what will you see around here? Of course, since they're gas, you're going to see bubbling. Remember, this is asking you to observe, so you do not need to write an equation. The ionic equation for the reaction between bromine and sodium iodide is this one. Why is this a redox reaction? It's giving you 2 marks, so we can say that both oxidation and reduction are happening at the same time. Okay, so you should get 1 mark from it. So another way that you can score is I minus, or iodide ions, is oxidized to I2 gas, and Br2 gas is reduced to bromide ions or Br minus ions. Okay, so this is going to allow you to score 2 complete marks. Bromine can be obtained from bromide ions in seawater. Chlorine is bubbled into seawater, and this becomes the bromine atoms form bromine molecules. Okay, so complete the equation to show bromine atoms are formed from the bromide ions. So CO2, 2 CO minus, so we need to balance the charges, so this should be 2. Since we have 2 Br minus, we should have 2 Br. So normally this would be wrong, okay? This is because the exam question is asking you specifically for bromine atoms. This is correct, but normally it's Br2 gas, okay? State why this reaction is described as oxidation of bromide ions. It's because the charge on Br minus, okay, the charge on Br minus, it increased from -1 to 0 on Br. Okay, so that's why. So you can also say that it loses electrons. Okay, this or loses electrons. Anything that is okay. So you get 1 mark here, 1 mark here. Write an equation to show how bromine atoms form bromine molecules. So your bromine atom is Br, right? So a bromine molecule is Br2. So you're going to require another bromine atom. Okay, and Br2 will be gas as well. So 1 mark here. Alright, so zinc metal is obtained from sulfide ores. Okay, so pause the video and try to read through this paragraph. Now state how the reaction in stage 3 shows that zinc is more reactive than cadmium. So we can see here that zinc has displaced cadmium. Okay, so zinc is more reactive than cadmium because zinc has actually displaced cadmium ions, Cd2 plus ions here, okay, to form Zn2 plus. Write an ionic half equation for the reaction that occurs in stage 4. So what is stage 4? The solid cadmium is filtered off and pure zinc sulfate solution is electrolyzed. Okay, so zinc is deposited, right? Zinc is deposited on the cathode. So your answer, okay, B1, right? I'm just going to write it here. So zinc is deposited at the cathode. So at the cathode, it is a reduction reaction. So it should be Zn2 plus 2 electrons would give you Zn solid. Okay? Alright. Alright. So explain how the pH of, okay, sorry, I'll skip a question. So complete the ionic half equation for the reaction occurring at the anode. So let's try to balance the number of hydrogen first. So we have 2 hydrogen on the left, 1 hydrogen on the right, okay, and oxygen is 1, 2. Okay, so let's try to balance this. We can multiply this with 2, multiply this with 4. So our charge is 4 plus here. So we need 4 electrons to balance it out. Alright, so explain how the pH of solution surrounding the anode changes during the electrolysis. Okay, so remember here that H plus is being formed around the anode, right? So meaning what? That if your hydrogen concentration is increasing, it means that your pH is going to decrease. Okay, so this is something that you will learn in acid bases and salt preparations in later chapters, but right now just know that your hydrogen concentration, if it increases, pH is going to decrease. So pH is going to decrease because hydrogen ion concentration is increasing. Alright, so notice how I am trying to answer based on the marks given. Okay, if it is 2 marks, I'm trying to get 2 complete marks. Alright, question 5. This is fairly simple one, so pause it and try it yourself. Okay. Alright, so reaction A. In reaction A is the species, which is Al3 plus, oxidized or reduced. Since it is from Al3 plus to 0, it is reduced. Okay, what is the explanation of my choice? Because I gained 3 electrons on the left side, right? So you can see that Al3 plus gained electrons. So for CO2, let's see if this is actually oxidized or reduced. Okay, so what do you think? Alright, so it is oxidized because in C, right? Let me show you this. C plus O2 will become CO2. So meaning that the charge was 0 here initially. Give me a second. Okay, the charge was 0 here initially. For CO2 to happen, right? Since O is -2 and there's 2 oxygens, so this is -4. So carbon must be +4 here. Okay, so this is oxidized. And why is it oxidized? You can of course say that it loses electrons, or obviously you can also see here that it gained oxygen as well. Okay, alright, so that's 3 marks for you. Okay, so you should be getting this. Alright, question 6. Student writes this half equation. Show which reaction with the brown substance forms. Identify 2 mistakes in her half equation. So first mistake that I can see here is that the electron is put on the wrong side. Okay, so you can say that electron should be on the opposite side. Okay, because why? The charges are not balanced. But the front answer is more than enough. Okay, the charges are unbalanced as of now. And another thing, if you notice here, is that the 2Br is totally wrong. So right here, 2Br must be Br2 gas. 1 mark for this, 1 mark for this. So 2 marks. Explain why the lamp stops working after the teacher stops heating the lead to bromide. So when you stop heating it, what happens? Okay, when you stop heating, as I explained in my second video, okay, when you stop heating, the ions will stop to move. Okay, so when the ions stop to move, there will be no flow of electrons from the battery. No flow of electron from the battery, and that is why the lamp will stop working. But it's your answer can stop at the ions will stop to move. Okay, you can score 1 mark just with this. Alright, so apparatus shown in the diagram can be used to investigate the colors of cobalt. Okay, we're trying to investigate color, so that's your question here. Okay, cobalt 2 CO2 plus and chromate CrO4 2 minus. So this is our positive ion, cation, and this is our negative ion, anion. Okay, so these are the results of the experiment. Pink color moves towards electrode A and yellow color moves towards electrode B. Explain how these 2 results show that the chromate ion is yellow. Okay, let's take a look at this. So what is electrode B? Okay, electrode B is anode, right? So electrode B is anode, which is our positive electrode. So what should be attracted towards it? CrO4 2 minus should be attracted, okay? Which is the chromate ion, right? CrO4 2 minus, since it is an anion, it will be attracted towards the electrode B, and they say that yellow color moves towards electrode B. So that's how you get 2 marks, okay? Mention that anion is 1 mark, and then mention that anion or CrO4 2 minus is going to be attracted towards electrode B. From here you get another mark, so just 2 marks. B1. This is pretty simple. It's just asking you to balance the equation. So when you are presented with long equations like this, right, try to ignore the single one like this. Ignore them, okay, because you can always come back to those later. Figure out the complicated ones. So there's 2 chromium, so I'm just gonna go ahead and multiply this with 2. So how many oxygens do I have on the left? 2, 4, so I have total of 8. On the left right hand side I have 7, 1, so this is 8 oxygen. Okay, so I only need to figure out my hydrogen. I have 2 hydrogen on the right, so I should have 2 hydrogen on the left. And is my charge balance 2, 2, minus 4, plus 2, so this is a total of negative 2. This is a total of negative 2, okay. So it's balanced already, okay. Alright, so make sure that when you're balancing this equation, try to make sure that your charges are balanced and your number of atoms are balanced, okay. You should score these marks 100%. Alright, the apparatus is used to test magnesium, magnesium chloride, and aqueous solution. Alright, so magnesium, explain the results with reference to type of particles. Alright, so magnesium is able to conduct electricity. Why? Because it is a metal, and metals will have delocalized electrons, and then the movement of these electrons will allow electricity to flow, okay. So for this you get 1, 1, so you already score 2 marks for magnesium. For solid magnesium chloride, no. Why? Because it's Mg is metal and Cl minus is non-metal, meaning that it is a solid ionic compound. So solid ionic compound doesn't conduct electricity because why? Ions are held together very strongly by electrostatic attraction. Okay, I'm not writing down complete answers because I want you to get the idea about how to answer them. Okay, so so meaning that ions are not free to move. This is also your keyword. Ions are not free to move. So you get mentioning 1 mark for this one, 1 mark for this one. So you get 2. Aqueous solution of magnesium chloride. Alright, so it's definitely going to conduct electricity because why? Because when it is aqueous, MgCO2, the ions become free to move. Okay, so your positive ions will move towards the cathode, and your negative ions will move towards the anode. Right, so for mentioning this you get 1, for mentioning this you get 1. Okay, so you get a total of 1, 2, 3, 4, 5, 6, 6 marks for this question. Okay, alright. A teacher uses this apparatus to demonstrate the electrolysis of molten zinc chloride. Alright, so state what is meant by the term electrolysis. Okay, very simple. It is the breakdown, okay, or decomposition of a compound, or you can say that you pass electricity through an electrolyte and a chemical change takes place. Okay. Alright, state why graphite is more suitable to use than magnesium, because graphite is inert, meaning that it won't react with others. Sorry, this is very repetitive. I put a mistake here. Alright, which of these correct statement is true for the electrolysis? Alright, A, B, C, or D. Your option should be B. Okay, which of these correct statement is which of these is a correct statement for this electrolysis? Both products should be elements. Okay, because when molten zinc chloride is electrolyzed, okay, this is molten zinc, right? So the equation should be ZnCO2. You're going to get Zn2 plus and then Cl minus, and Zn2 plus will form zinc. Cl minus, this will form zinc solid, and then Cl minus will form CO2 gas. So your only answer is both products are elements. Student is writing the half ionic equation for the reaction that forms the pale green substance. Identify 2 mistakes. You know this already from previous question. You know this from the previous question already. Question 10. So this is asking about the negative electrode and positive electrode products. If it is silver sulfate, right, as I mentioned, it's Ag plus and SO4 2 minus. Since it is a solution, we will have H plus and OH minus. Silver is less reactive than hydrogen, so your product would be here is silver. Alright, for potassium nitrate, which is K plus and NO3 minus, and solution, so H plus and OH minus. So H plus will be produced, and between these two, which one is it? It's going to be OH minus, right? So since OH minus, it's going to be oxygen. The substance which is left, so it's asking about the remaining solution, okay? So hydrogen will be gone, OH minus will be gone, so we are left with K plus and NO3, which will allow us to have simply KNO3. So write this in what, right? Potassium nitrate. So suggest a suitable element. You know that this should be graphite. Why should you add a small amount of dilute acid? So why do we add a small amount of dilute acid? It is to increase the electrical conductivity, okay, of our electrolytes. So use this equation to explain why the volume of hydrogen collected should be twice that of the volume of it. So it says use the equation, right? So use this equation. So from this equation, you can see that 2 mole of H2 is equals to 1 mole of oxygen, meaning that the volume of hydrogen will be twice. And now this question is quite experimental, okay? So it says that the volume of oxygen is always less than expected, although you do not have any leaks. Why? It's as I said in my lecture, because oxygen is way more soluble than hydrogen in water, okay? And that's why some of the water is lost, and that's why it's slightly less than expected. Alright, now we've got this set up for sodium chloride concentrated. Okay, state how the ionic half equation shows that equal volumes of the two gases should be collected. So we're talking about volumes, right? So let's try to look at this. So 2 electrons should produce 1 mole of CO2, and 2 electrons should produce 1 mole of H2, okay? So that's how it's proved from equation 1. You can simply write this, or you can say that equal amounts of gas can be produced from the same number of electrons. Suggest why the volume of chlorine collected is less than expected. So why is it that? Okay, it's repetitive right now. It's same as either oxygen or chlorine. It's because CO2 is more soluble in water than hydrogen. A sample of the solution near to the negative electrode is tested with phenolphthalein indicator. Why does it turn pink? So turning pink means that it becomes alkali, right? Because if it turns red, it's acid. If its color is softer, it's alkali. Alright, so where is anode? So near our anode, which is our positive electrode, why does the phenolphthalein indicator turn pink? Okay, also sorry, negative electrode. So near the negative electrode, what are we producing? If you look at this, look at your product, we're producing hydroxide ions, okay? So you can simply say that we're producing hydroxide ions, and the hydroxide ions will make the solution alkali. Alright. Explain why metals conduct electricity but covalent compounds do not conduct electricity. Alright. So metals conduct electricity because you already know about this, is because of delocalized electrons first of all, and then it's because of the movement, okay, of these delocalized electrons. So from here you score 2 out of 4 already. But let's see, why does covalent compounds do not conduct electricity? Is because covalent compounds or covalent bonds, okay, so hold together, they hold together the electron very strongly, okay? For example, you do not need to give examples, okay? I'm just giving you an example. If it was hydrogen, there is a covalent bond, okay? So the covalent bonds will hold together the electrons very strongly, so meaning that electrons are not are not free to move around. Okay, and that is why it's not able to conduct electricity. If you get this 2 point, it's 4 out of 4 already. Alright, so that is all for the past year practice paper for electrolysis chapter, and I hope it's useful, and I'll see you again in the next video. Bye bye.